The parametric equations of the curve C are x equals 2 over t and y equals 4t. Show that the tangent to C at the point P with parameter P has equation y equals minus 2p squared x plus 8p. The tangent to C at the point P passes through the point 2, 3. Show that P can be one of 2 points. Find the coordinates of each of these 2 points. So let's have a look at this then. Here's the question summary. So let's do part A first. We're going to need dy dx to get the tangent, the gradient of the tangent, so we need dx dt. So let's get that first. 2 over t is 2t to the minus 1, so a minus 1 comes to be with the 2, t to the minus 2, which we can write like that. And then dy dt. Differentiate this, t differentiates to 1 and there's 4 lots of, so that goes to 4. So dy dx then, dy dt divided by dx dt is 4 over, and then we've got minus 2 over t squared, haven't we? So the 2's will cancel, the minus can come to the top to leave 2, the t squared can swing up to be with this from underneath, can't it? So there's dy dx is what we should have written here. Let's just put that in. Okay, so that's dy dx, and the gradient of the tangent with parameter p. So at the point P then with parameter p, dy dx, gradient of the tangent is equal to minus 2p squared, isn't it? So now we can write down the tangent. So the parameter p, so x is equal to 2 over p squared. 2 over p, wasn't it? Y at p is equal to 4p, just letting t equal p. So, and the gradient is this. So the equation will be y minus this point is equal to the gradient, minus 2p squared, x minus 2 over p. So let's see what we get. What form do we need to write it in? Y equals, so let's leave the y as is. There's going to be minus 2p squared x when we expand the bracket. Then we've got 4p, which will move over to the right hand side. And minus times a minus is a plus. 2p squared times 2 is 4. The p, one of the p's will cancel and it'll just be 4p, won't it? So we've got then, in other words, y equals minus 2p squared x plus 8p, and that hopefully is the equation of the tangent that we wanted to show. Great. The tangent at P passes through the point 2, 3. Show that P is one of 2 points and find the coordinates of each. So this line then goes through 2, 3. So at 2, 3, let's put the values in. 3 will equal minus 2p squared times the x value, which is 2, plus 8p. So let's move these over there. So that will be 4p squared with a minus moves over to plus. Move this 8p over to minus 8p. The 3's already there as is, and there's nothing left on the other side. So that's a quadratic in P, which we can solve. Hopefully we can factorize. Yeah, I'm going to go for 2 and 2 because 3 ones are 3, and also that will give a product of 8. So 2p and p, 3 ones, and that will make 8, won't it, if we do a minus and a minus. 2p squared? Oh, we need a 2p as 4p squared, that's it. Minus 6 minus 2, which is minus 8, and then minus times minus is a plus. 3 ones are 3, so that's fine. So this gives us 2 possibilities then. This one is 0 when p equals a half, and this one is 0 when p is equal to 3 over 2, isn't it? So here's our 2 possible values of p. So coords are then, so the coordinates are, well, basically these are the x and y values, so let's put them in. When p is a half, 2 over a half is 4, and 4 times a half is 2. And the next coordinate, when we put 3 over 2 in here, 3 over 2, 4 over 3 it'll be. Tap it in the calculator if you need to. And then 4 lots of p, 4 over 2 will be 2, 2 3s are 6. So there's our 2 possible coordinates.